Hi, welcome to the first video looking at enzymes. Our enzyme today is going to be from a potato, and you missed the best part of the lab, me taking a raw potato, peeling it, putting it in a blender with some water, and then making a potato smoothie. I really don't like potato smoothies, but what I was doing was taking that poor innocent potato and ripping apart the cells, breaking open cell walls, breaking some of the bigger cell membranes, and releasing the enzyme tyrosinase. So our potato smoothie is the source of our enzyme. And I'm going to put some of this in a test tube. I'm also going to add just some plain water. And then to that enzyme and water mixture, I'm going to add our substrate. The substrate is the reactant in an enzyme catalyzed reaction. This is what's going to be changed, what's going to be consumed in our reaction. And if you'll notice to begin with, it's a clear liquid. Add some of that to our test tube. And I'm also going to thump it just to stir it, and then we're going to set it aside for a few minutes. So notice right now it's kind of cloudy because of the potato smoothie that I added in there. We're going to have a second test tube that's going to be our control. I'm going to add water, just like I did to the first one. I'm going to add substrate, just like I did to the first one. But this time, I'm not going to add the enzyme. Again, I'll thump it to get it started. A little bit more clear because it didn't have the potato chunks in with this one, but this contains water and substrate, no enzyme. To a third test tube, I'm going to add water. I'm going to add our potato enzyme. But this time, I'm going to try a different substrate. We're going to try sucrose instead of the catechol. So one of the things I want you to think about is the fact that an enzyme, first of all, is a protein, and they have a specific shape. And so let's imagine that my hand here is our enzyme. On that enzyme is a place where the substrate, the reactant, has to attach. And so let's assume that's this curved portion here. That's the active site. That's the place where our substrate has to attach. So if this is the proper substrate, the two fit together, and our enzyme can function as a catalyst. If we have a different molecule, different shape than our substrate, notice that it doesn't fit with this enzyme. This enzyme cannot catalyze reactions with this molecule because it doesn't fit into the active site. So let's go back and check our first test tube. Hasn't been a full 5 minutes yet, but notice we're getting a brown color, kind of a pale iced tea kind of color. And what that tells us is our enzyme is functioning. Our substrate's being converted to a product, and we know that's happening because of the brown color that we see starting to develop in this test tube. In the second test tube, I added the substrate and water. I didn't add the enzyme. And notice that it's still perfectly clear. The one that contains the sucrose instead of our proper substrate still looks cloudy. So as we wait, test tube number 1 is going to continue to get darker and darker. Our enzyme catalyzed reaction is occurring very rapidly. But I have a trick question for you here. In this test tube, I put substrate and water, did not add the enzyme. Is the reaction occurring? It actually is. But much, much, much slower. With the proper enzyme, thousands of times faster than without the enzyme. Now, I'm not going to make you wait this long, but if we were to wait for days, this one would eventually turn brown. So enzymes don't make reactions occur, they speed them up, often speeding them up thousands of times.